Hello, 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 everybody. Hello, Naru. Hi, 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 hi. Hi, all of you. Hi, hi, hi. I hope everything is good. Am I audible? అందరికి ఒకసారి చెప్పండి. Is everything clear, all of you? Okay, okay, okay. So, yeah. So, everybody present, not present. You are sleeping. Sir, we are sleeping. Okay. Okay, okay. Right. Because there are some dates and clashes, Ra. I have decided to take a small chapter. Small chapter ante, the name of your chapter is EM waves. Electromagnetic waves. Okay. Hi, good evening, all of you, good evening. Very good evening, Andariki. So, if at all I have to talk about the weightage in the NEET question paper, you try to understand, Ra. If you talk about last 15 years question papers, in 15 years low, somewhere around I can expect 45 questions have been asked. Okay? From last 15 to 20 years. So approximately, me exam low, you can at least, okay? Okay, hi Karthik, hi, very warm welcome Karthik. If it's your first time, very warm welcome. Okay, anyways, so if 45 questions, if you're distributing, you can at least expect 1 to 2 questions, okay? At least expect 1 to 2 questions from this chapter. EM waves. The biggest benefit, perk to study this chapter is hi. Very good evening, Parimala, good evening. Yeah. The biggest benefit or perk to study this chapter is because you will be asked 1 or 2 questions and the questions will be very easy, very easy. Okay, sir. The chapter is absolutely theoretical chapter, okay? Ardham cheskondi, theoretical chapter. Andariki. Hi. Okay. And the second important thing is, ఇది చాలా చిన్న చాప్టర్ అంటే it will be completed in 2 hours. 2 hours అంటే more than sufficient to understand this chapter అందరికి. Okay? So without wasting our time, start చేద్దాం అందరికి. Okay. So EM waves అంటే electromagnetic waves. చూసుకోండి. Why we study? ఎందుకు స్టడీ చేయాలంటే because it is there in our syllabus. Is it useful after your exam? Not really. Except if you are going for your radiology, X-rays and all these things, MRI, there it is useful, Kani. Whatever you are studying here is going to stay here only after your examinations. Okay? Perfect. Hi, Meghna, hi, hello. Just so, the purpose of studying this chapter is just because to crack the examination. Malli, you see the flow. That flow is divided into two different flows, I would say. The first one is your Maxwell's laws. Ade kada? Yes. The first part is your Maxwell's laws of electromagnetism. Dan tarvata, the second part is your EM waves. EM waves ante the information regarding your EM waves, what are they, why they are created, energy and the relationship between various factors. Okay? I'm fine. I'm absolutely fine. Yeah. Perfect. Just good. So first, let us talk about Maxwell's laws and entira. Let us talk about some experiment. So in experiment lo, we are going to talk about your displacement current. Andariki. Displacement current. Displacement. It is a little important topic. I can expect from last 5 years, it has been asked almost every single year. Okay? Very important. Very important topic. what do you mean by displacement current? Ee displacement current ni ardham cheyadaniki you have to go to your magnetism ra. Magnetism. In magnetism lo you have a concept. What's an Ampere circuit law? Ade kada? Yes. So let us talk about a very general case ra. Oka wire teeskondi, and in this wire let us say that the current I is flowing. Emaitadi sir? Emaitadi ante due to the current there will be the creation of magnetic field kada? Yes. So ee wire ki adjacent lo I am placing a bar magnet leda compass ra. Okay? Ide na bar magnet. What will happen, sir? What will happen ante there will be deflection. Enduku? Because the magnetic field have been created. Ade kada? This is what we have studied in magnetism. Andariki. This is what we have studied ra. What did we study? A moving charge creates a magnetic field around itself. Ide kada? Yes. Very good. Very good. Ippudu chudandi. So I am replacing the entire scenario with a capacitor. Capacitor, sir. Why we are taking capacitor? Because it was the place where Maxwell, chudo, Maxwell, vadu, he started his experiment. What did he do? He took an parallel plate capacitor. Okay? దాని తర్వాత he connected it with a battery. Battery అంటే తెలుసా? Okay. Expectation was what? What was the expectation రా? Okay? Okay? చూసుకోండి. So the current I is flowing into the circuit. No problem, sir. Everything is perfectly all right. మరి ఇప్పుడు ఏం చేయాలంటే you place a bar magnet రా. Bar magnet no. You place a compass. Compass అంటే magnetic needle. Okay? You place a magnetic needle. How should I place, sir? Okay. Let us say this is my magnetic needle. అందరికి చూసుకోండి. Okay? ఏమైంది అంటే this needle got deflected over here. No problem. Nothing was surprising. Everything was perfectly all right, sir. ఇది current carrying wire కదా. Yes, so it will create a magnetic field. A magnetic field valla this magnetic needle is getting deflected. No problem in that. Ardhamaindi? Very good. So this is a magnetic needle. So what did we do? We simply lifted this magnetic needle ra, and you place it here. Ekkada kuda there was a deflection. Ardhamaindi? Endukante here is also current, and due to this current the magnetic field is created. You lift it. You lift it. Emaitida? What's happening, sir? What's happening ante I think you'll have to take. Right. Again you lift it. You shift it there. Magnetic deflection happened ra. Okay? Magnetic deflection happened. Ekkada kuda malli okasari you lift it. Okay? You lift it and you shift it there. Deflection. Here also deflection. Here also deflection. Kaani ardhamaindi. Ippudu what he did was he actually lifted and he placed it between the plates. Hey babu, emaindira? He placed the needle between the plates. What was the expectation? Chuskondi andariki. The expectation was, chusko. Expectation was no deflection. Ide kada? Enduku no deflection, sir? Because there is no current between the plates ra. Chusko. A current near the medium kada. It only travels through the wire ra. ఏదైనా వైర్ ఉంటుంది రా ఈ ప్లేట్స్ కి మధ్యలో నో వైర్ కదా సో నో వైర్ అంటే నో కరెంట్ if there is no current there should be no magnetic field ade kada yes so expectation was there should be no deflection in the needle ade kada yes so that was the expectation and the needle should not deflect kani what was the result ra what was the result cheppu andariki what was the result ra result was different result choosy the result was telling that the needle was deflected. Oh my god, the needle was deflected. Enduku sir, what could be the reason? Cheppandi andariki. The needle was deflected. Ante what's happening, sir? So a needle ni deflect cheyadaniki we need current kada. So there is no current over here. Then why is it getting deflected? Cheppandi andariki. Why is it getting deflected? That was the problem. Ante kada? Yes. So even before this, ee mottamni discuss chesin mundu I will like to tell you something about Ampere circuit law. What is the formula? First of all cheppandi. Ampere circuit law. Gurtunda? Ampere circuit law. No sir, we don't remember anything. Kabatti I am here ra. Therefore I am here. Cheppandi. Ampere circuit law tells you closed integral of b bar dot dl bar is equals to చెప్పండి, what is it? Mu naught into I inside రా, అదే. This is your Ampere circuit law కదా. Very good. ఇప్పుడు let us try to ask Mr. Ampere the solution ఎందుకు this whole setup is happening రా. So Mr. Ampere was asked this question. చూసుకోండి అందరికి, okay? Ampere was asked this question. నా దగ్గర ఒక parallel plate capacitor ఉంటే you are connecting this capacitor with a battery, అదే కదా. Yes. So ఈ బ్యాటరీ నుంచి there is a current flowing రా. Current I is flowing, current I is flowing. అందరికి జాగ్రత్తగా వినండి. Current I is flowing, ఎక్కడ కూడా the current I is flowing. Charging and discharging of capacitor అంటే there is a phenomenon. We are not discussing all of those things, okay? We are not going into the technical details of the concept. Can you try to understand రా? Try to understand. When you are taking the plates, ఏమైంది? What is happening in the beginning place? You try to tell me that first. చెప్పండి అందరికి. So can I simply say that initially మొదటిగా there was no charge on the plates, అంటే Q initial value was 0. ఎక్కడ కూడా there was no charge అంటే Q initial value was 0. As the current is flowing అంటే ఏంటిరా? Electrons are flowing కదా. Yes, చూసుకో, ఇదే పాజిటివ్ టర్మినల్ లెఫ్ట్ సైడ్ లో ఉంటే this plate will also have a positive charge, అదే కదా. అంటే ఏంటిరా? The electrons from this plate they are getting removed రా, and ఎక్కడ నుంచి they are getting deposited on the other plate. చూసుకో, they are electrons, they are flowing due to the battery, they are flowing from one plate to another plate, ఇదే కదా. సో కొంచెం సమయం తర్వాత electrons are getting lost, అంటే this plate will have a positive charge. అందరికి చూసుకోండి. And ఈ ప్లేట్ లో electrons are getting added up అంటే there will be a negative charge, ఇదే కదా. Try to understand. చెప్పండి. Yes, yes, very good, very good, very good, very good. Okay, perfect. So what is happening because of the charges, sir? What is happening because of the charges? చెప్పండి. Due to the charges, okay, perfect. So the first plate is getting positive charge and the second plate is getting negative charge, అంతే కదా. Yes. Right. చూసుకోండి. So let us do one thing. This is my final scenario అంటే కొంచెం సమయం తర్వాత there is some charge రా. I would not say 0. Okay, it's not 0. ఇప్పుడు after some time some charge has been induced కదా. Yes. So not induced, deposited రా, deposited. After some charge has been deposited. Let us say it is plus Q, it is minus Q రా. జాగ్రత్తగా వినండి, ఇదే కదా. Yes. Experiment. What does the experiment say? ఇప్పుడు I have to put a magnetic needle between the plates రా, ఇదే కదా. Yes. What's happening, sir? As soon as I place the magnetic needle, it is getting deflected, ఇదే కదా. Deflection చూసుకోండి అందరికి, జాగ్రత్తగా వినండి. Whenever there is a deflection in a magnetic field, we don't know anything రా. We will try to connect the links, we will try to connect the links. చూసుకోండి. What was the observation? Observation was this needle got deflected, అదే కదా. Observation number 1, this needle got deflected. ఇప్పుడు the current is still flowing, okay? The current is still flowing. Capacitor is still charging. It has not been charged fully. Ante entira? Ante it is in the middle process. At the final stage, end stage lo, your capacitor will get fully charged. Ade kada. Dan tarvata there will be no current in the circuit. Ante that would become the steady state of your capacitor. Gurtunda, I have told something about the steady state in your capacitors chapters. Andariki. Okay. Yes, we'll do it, no problem. చూసుకోండి. అంటే this is your intermediate state. Intermediate state. Observation number 1 రా, చూసుకోండి. It is your intermediate state. ఎందుకు సార్? బికాస్ ఎందుకంటే ఒకసారి నీ స్టడీ స్టేట్ అచీవ్ అయింది అంటే యూ కెన్ నాట్ సే దట్ ద నీడల్ విల్ డిఫ్లెక్ట్. అబ్జర్వేషన్ నంబర్ 1, ఎవ్రీథింగ్ ఆఫ్ ఇట్ ఈస్ ద ఇంటర్మీడియట్ స్టేట్. అర్థమైంది కదా. ఈ ఇంటర్మీడియట్ స్టేట్ లో when you are putting the magnetic needle between the plates, ఏమైంది అంటే ఇట్ ఈస్ గెటింగ్ డిఫ్లెక్టెడ్. సార్ మ్యాగ్నెటిక్ నీడల్ డిఫ్లెక్టెడ్ అంటే ఏంటి సార్? దెర్ ఈస్ అ మ్యాగ్నెటిక్ field, sorry, magnetic needle deflect అయింది అంటే ఏంటిరా, there is a magnetic field, అదే కదా, yes, magnetic field is there. ఎందుకు ఇంత కన్ఫ్యూజన్ సార్? బికాస్ we cannot see we cannot see electric field, we cannot see magnetic field, we cannot see charge, we cannot see current, అదే కదా. That is the reason why we are relying on the observations రా, చూసుకోండి. So it has been deflected అంటే there is a magnetic field between the plates. Observation number 1 ఇదే కదా, yes. So ఇప్పుడు magnetic field ఉంటే we will bring Ampere's law into the scenario రా, చూసుకోండి. What does the Ampere circuital law states? It states closed integral of b bar dot dl bar is equals to mu naught into I inside. అదే కదా, yes. So ఇప్పుడు what I am doing is I am trying to imagine an Ampere loop రా. Ampere loop అంటే ఏంటి రా? ఇదిగో, this is your Ampere loop. Some imaginary circle రా, some imaginary circular loop. చూసుకోండి. The question is there any current? Is there any current flowing between the plates? No. No current flowing kada. There is no current flowing between the plates. Kani some magnetic field is there. Cheppandi, Ampere circuital law states that your closed integral of b bar dot dl bar ide kada should be equals to mu naught into I inside ra. B bar constant unte you take it out of the integration, బయటికి తీసుకోండి, and you can simply say sir b into closed integral of dl bar should be equals to mu naught into I inside, అదే కదా, yes. So b multiplied by చెప్పండి small dl అంటే ఏంటి రా, the total length of the loop కదా, అంటే 2 pi r. ఈ లూప్ కి రేడియస్ r ఉంటే you can simply say sir integral is 2 pi r should be equals to mu naught into I inside, అదే కదా, yes. So that means your b should be equals to mu naught into I inside divided by 2 pi r. But the inside current is zero ra, zero. There is no current between the plates of the capacitor, అదే కదా. So if there is no current, ఈ ఫార్ములాలో I కి వాల్యూ జీరో రా. If I is zero ఉంటే ఈ మొత్తం వాల్యూ ఆల్సో టర్న్స్ అవుట్ టు బి జీరో, అంటే మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ జీరో. సో మీరు ఫార్ములాని చూసి యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ కమింగ్ జీరో, కానీ వెన్ యూఆర్ డూయింగ్ ద ఎక్స్పెరిమెంట్ బై పుట్టింగ్ ద నీడల్ రా, అందరికి దిస్ ఇస్ గెటింగ్ డిఫ్లెక్టెడ్. Contradiction. Are you understanding? Contradiction. What contradiction, sir? Needle says magnetic field is there. Formula says magnetic field is not there. Mari, what is right? What is correct and what is not correct? Understanding? So, in case law, what they did is, they thought this is the formula given by Ampere circuital law. Ante Ampere kada? Yes. Ampere ante chala big scientist ra. So let us do one thing. Let us respect him, okay? So we are respecting Ampere a lot. He is a very big scientist. The current unit is named on his name ra. Kabatti, he is a very big scientist. We will respect him and we will deny this formula ra. Okay? Enduku sir? Because there was one more scientist, Maxwell. James Maxwell. There was a cricketer also, right? I am not understanding the name. I usually get confused between these two, okay? Maxwell ante oka scientist ra. He came into the scenario and he said to Ampere, em cheppadante, he told Mr. Ampere, మీ ఫార్ములా is right, కానీ ఒక చిన్న కరెక్షన్ ఉంటుంది ఈ ఫార్ములాలో. వాట్ ఈస్ ద కరెక్షన్ అంటే, he said that the Ampere formula should be revised. చూసుకోండి, the closed integral of b bar dot dl bar should be equals to mu naught into not just I inside ra. I inside must be there, కానీ at the same time there should also be some other current ra. Other current అంటే ఏంటి? Yes, not 40 marks. I do have a full plan strategy of scoring 140 plus ra physics lo. At least you can score 140 plus from right from this stage, okay? This stage. What is the date? 20th January kada. Okasari these 15 days are gone. my guarantee is gone. Okay, good. Yes, RCB player kada. What is his name, ra? Maxwell is there, but I don't know his name, ra. I don't know his beginning name. So I get confused. And James Maxwell is that cricketer or this scientist? Okay? I do have sometimes confusion. Choose. Anyways, choose. Here. So what did he say, sir? He said that your formula is right till this place, ra, and you are missing some other information. Other information ante enti? Newton's first law lo gurtunda? Newton's first law lo, what did we say? We said that in non-inertial frames of reference. Hey, what are you talking, sir? What are you talking, sir? Forget everything, okay? Pseudo acceleration. Glenn Maxwell. Oh, right. Glenn Maxwell. So, vaadu ante Glenn Maxwell, he is James Maxwell, okay? These are the two different names. I used to get confused because I don't know this cricketer's name, Glenn Maxwell. Right. Cleared. Thank you so much, okay? Thank you so much, Ratnadeep, for clearing my doubt. I'll remember, okay? Glenn Maxwell. Anyway, చూసుకోండి here. ఈ కేసులో when we are talking, hey, now I want you to take it to the Newton's first law. Pseudo force, pseudo acceleration. గుర్తుందా? Pseudo force, pseudo acceleration, sir. ఏం మాట్లాడుతున్నావు, sir? Pseudo force అంటే we used to say దయ్యం. గుర్తుందా? When we talked about Newton's laws, చూసుకో. If you are not studied, లేదా if you have not seen the lectures, go and see Newton's laws of motion. Okay? There we talked about pseudo force. అంటే ఏంటిరా? Effect is seen but no force. అర్థమైంది? Effect is seen but no force. ఎక్కడ కూడా the same thing రా. Effect is seen. Needle is getting deflected. అదే కదా? కానీ no magnetic field, no current. If there is no current, we will say that ఒక కరెంట్ ఉంటుంది and the name of that current is pseudo current. జాగ్రత్తగా వినండి. Pseudo current between the plates of the capacitor. You should not say there is no current, ra. There is a current. కానీ ఆ కరెంట్ కి పేరంటే displacement current, ID, ra. Why displacement, sir? Why not pseudo? Scientists were mad, so they gave this name, okay? Displacement current. Okay? Displacement current అందరికి రైట్. సో డిస్ప్లేస్మెంట్ కరెంట్ అంటే ఏంటిరా? ఎప్పుడైనా మీ దగ్గర ఒక ప్యారలల్ ప్లేట్ కెపాసిటర్ ఉంటే there is current in the wires. For sure, okay? For sure there is a current between wires. కాబట్టి అదే కదా, due to that same current the magnetic field is getting deflected. Sorry, magnetic needle is getting deflected, ra. Are you understanding? Okay? Are you understanding? Yes. The same needle is getting deflected between the plates also. అంటే ఈ ప్లేట్స్ కి మధ్యలో కూడా there is a current. కానీ that current is not the regular current. అందరికి జాగ్రత్తగా వినండి. That current is not a regular current. It has a special name, displacement current. Okay? ఎప్పటి నుంచి we are talking about your displacement current. అందరికి displacement current అంటే ఏంటిరా? Displacement current is a pseudo current, okay? Displacement current. It is a pseudo current. I displacement. Pseudo current, ra. When it comes to the scenario, when does it come to the scenario, ra? Yeah. Ratnadeep, we will be taking. Don't worry, okay? Don't worry. Choose. When will the displacement current come into the scenario, ra? Jagrataga vinandi. You try to understand, okay? Ippudu I don't know if you remember too much things. Endukante I have a lot of things to tell. Ee chapter lo I have a lot of things. Too much complicated things kuda, but I cannot say everything to you, okay? Because I don't know how much you are able to recall, ra. Recall, okay? Recall. Choose. Okay? Try to understand, right? మీకు గుర్తుందా when we were talking about your EMI chapter లో, electromagnetic induction chapter లో, it is one of the recent chapters, ra. వినండి. So if this is your magnetic field, చూసుకో. I told you about two types of magnetic field. One is variable, one is changing. అదే కదా variable magnetic field అంటే it is changing with respect to position. అదే కదా changing magnetic field అంటే it is changing with respect to time. So if you have a changing magnetic field, ఆ changing magnetic field లో మీరు ఒక కండక్టింగ్ లూప్ పెడితే ఏమైతుంది అంటే if your magnetic field is increasing, చూసుకోండి, your flux also increases, అదే కదా, and accordingly there will be the current induced. If your magnetic field is increasing inside, there will be induced magnetic field outside, అంటే మీ current it will flow something like this. చూసుకోండిరా, your current will flow something like this. అందరికి your current will flow something like this, ఇదే కదా. Current flowing అంటే charge flowing, and to move any charge, we need electric field. Hey, are you able to recall? I told everything in that chapter. చూసుకో. So to move this charge, we need the electric field. Electric field అంటే ఏంటి సార్? ఇప్పుడు try to understand. Okay, try to understand. అందరికి try to understand. మీ మ్యాగ్నెటిక్ ఫీల్డ్ వేరియబుల్ ఉంటే, అంటే చేంజింగ్ విత్ టైం, అంటే టైం వేరియబుల్ మ్యాగ్నెటిక్ ఫీల్డ్ ఉంటే, ఇట్ ఈస్ గివింగ్ రైజ్ టు ఇండ్యూస్డ్ ఎలక్ట్రిక్ ఫీల్డ్. ఇండ్యూస్డ్ ఎలక్ట్రిక్ ఫీల్డ్ B bar gives rise to induced electric field, అదే కదా, induced electric field. And what did I say? I've told you multiple things about it. This induced electric field will always exist in closed loops. Ade kada. Try to understand. Okay? Try to understand. Ante change in B bar will increase induced electric field. Reverse ante enti sir? Reverse ante your change in the electric field will give rise to induced magnetic field. Ade. Are you understanding? ఇప్పుడు come to this same scenario ra. What is the electric field, sir? Electric field between the plates is sigma by epsilon naught. అదే కదా. Sigma అంటే ఏంటి రా? Sigma is total charge upon area into epsilon naught. ఇదే. So this is your electric field, that is variable. చూసుకో, ఎందుకు వేరియబుల్ సార్? బికాస్ ద వాల్యూ ఆఫ్ Q అంటే చార్జ్ ఆన్ ద ప్లేట్స్, అండ్ ఐ టోల్డ్ యూ దట్ దిస్ ఈస్ ద ఇంటర్మీడియట్ స్టేట్. అంటే కరెంట్ ఈస్ స్లోలీ ఇంక్రీజింగ్, the charge is increasing, ante the charge is variable, ఎందుకంటే the current is flowing and the slowly the charge is increasing. So if the charge is increasing, it is variable. మళ్ళీ charge variable ఉంటే your electric field is variable, అదే కదా. Yes, and if your electric field is variable, it will give rise to a new magnetic field లేదా induced magnetic field, and induced magnetic field wala this magnetic needle is getting deflected, ade kada. Yes, so if you want to understand this concept in two ways, I have explained both the ways to you. The first way is your displacement current. So sir, how would you describe all of that into a formula? Ante ide, this is your formula. Andariki jagrataga vinandi. Okay, it's a very important formula, all of you. This is one of the formulas given by Maxwell, okay, James Maxwell Ra, right? And at the same time, when you try to understand using variable electric field also, ippudu we will only talk about your displacement current, ID, చూసుకోండి. So when to talk about displacement current? అంటే ఎప్పుడైనా మీ దగ్గర changing flux is there. అందరికి listen to me, okay, listen to me. So let us say this is your electric field, okay, E bar. Ide me electric field E bar, and this is your loop ante let us say area A ra, radius R తీసుకుంది అదే. Can you tell me what is flux, sir? Electric flux phi E is equals to E into A kada. Yes, so E bar dot A bar అంటే E bar is E, A bar అంటే pi R square. చూసుకోండి, ఇదే మీ ఫ్లక్స్ రా. now ఇప్పుడు అందరికి all of you, if this flux is variable, అంటే electric flux is variable with respect to time. చూసుకోండి, if flux electric is variable, అదే, if your flux is variable, automatically displacement current ID will be introduced. Understanding will be introduced. Hey, each and every single topic I am talking to you has a PYQ. Jagrataga vinandi. Each and every single thing I am talking to you has a previous year question in NEET. Ade kada, I've told you there are around 44 questions ra. Okay, perfect. చూసుకోండి అందరికి. So what is the formula for induced current ante? This is the formula for induced current. Vinandi andariki jagrataga. Induced current is nothing but epsilon naught multiplied by d phi by dt. Other. This is a very important formula. అర్థమైంది? d phi by dt అంటే rate of change of flux. అదే. Are you understanding? So to change the flux, we need a variable electric field. Adhe, this is the only way. This is the only way. Okay? Right. Perfect. So ఇప్పుడు let us talk about your displacement current. Okay? The equation is going to look a little complicated. Complicated ante, sir, there are too many things. Ippudu they are going to come. Okay? I want to tell you the Ampere circuit law. What was it, sir? Ampere circuit law ante V bar dot dl bar is equals to mu naught into I inside. అదే కదా? Yes. ఈ ఆంపియర్ తర్వాత జేమ్స్ మాక్స్వెల్ వచ్చాడు. He said that this formula needs a correction. ఆ కరెక్షన్ టర్మ్ ఏంటంటే you take a bracket. ఈ బ్రాకెట్ లో మీరు డిస్ప్లేస్మెంట్ కరెంట్ యాడ్ చేసుకోండి. ఇప్పుడు ఫ్రమ్ ద లాస్ట్ స్లైడ్ ఇఫ్ యు ఆర్ టేకింగ్ ద వాల్యూ ఆఫ్ డిస్ప్లేస్మెంట్ కరెంట్ రా సబ్స్టిట్యూట్ చేసుకోండి ఈ ఫార్ములాలో. సో యువర్ ఇంటెగ్రల్ ఆఫ్ V bar dot dl bar should be equals to mu naught into inside current ante internal current plus induced current ante entira epsilon naught into d phi divided by dt. Ade. So this is your Ampere-Maxwell formula. Ade kada? Yes. You can say this is your Ampere-Maxwell formula. లేదా Ampere-Maxwell law ఏదైనా you wanna call whatever you wanna call. Okay? Law లేదా formula అదే చూసుకో. This is the actual formula. ఇప్పుడు when you analyze this formula for a parallel plate capacitor అందరికి when you are analyzing this formula for a parallel plate capacitor అందరికి జాగ్రత్తగా వినండి. Okay? I am now going to derive one more formula out of it. చెప్పండి, the left plate, can I say that the left plate will get a positive charge and similarly the right plate will get a negative charge. అదే కదా? Let us say, right, let us assume that this charge is plus q and ఎక్కడ వచ్చి ఇదే minus q charges ఉంటే what did we say about field ra? Field is sigma by epsilon naught. Sigma by epsilon naught. Capacitor chapters, good petkondi, try to understand. Okay? There the field is sigma by epsilon naught. Sigma ante q upon area ra. Charge upon area. Sigma divided by epsilon naught. Ide mi electric field. Ante kada? Yes. So ఇప్పుడు ఏం చేయాలంటే I'll just take it a little away. Leda I'll write over here. Okay? This is your electric field inside. ఇప్పుడు ఐఎమ్ ఇమాజినరింగ్ an ampere loop. అందరికి వినండి, దిస్ ఈజ్ యువర్ ఇమాజినరీ లూప్, రేడియస్ ఇస్ ఆర్. చూసుకోండి ఆల్ ఆఫ్ యూ. ఓకే? రేడియస్ ఆర్ ఉంటే ఇప్పుడు దేర్ ఆర్ ఫీల్డ్ లైన్స్ కదా, ఫీల్డ్ లైన్స్ ఫై ఈజ్ ఈక్వల్స్ టు ఈ బార్ డాట్ ఏ బార్. చూసుకోండి, ఏరియా ప్లేన్ ఇస్ పర్పెండిక్యులర్ అంటే ఏరియా వెక్టర్ షుడ్ బి టు ద రైట్. యువర్ ఎలక్ట్రిక్ ఫీల్డ్ ఈజ్ ఆల్సో టు ద రైట్. అంతే కదా? ఎస్. సో ఐ కెన్ సింప్లీ సే ఈ ఇంటూ ఏ, లేదంటే యువర్ ఎలక్ట్రిక్ ఫీల్డ్ ఎంత వస్తుంది సార్? ఇట్ ఈస్ కమింగ్ అట్ క్యూ డివైడెడ్ బై ఏ ఇంటూ ఎప్సిలాన్ నాట్ అందరికి మల్టిప్లైడ్ బై యువర్ ఏరియా ఇస్ ఏ. ఇదే మీ ఫ్లక్స్ రా, ఏ గాన్ అంటే మీ టోటల్ ఫ్లక్స్ ఇస్ ఈక్వల్స్ టు క్యూ బై ఎప్సిలాన్ నాట్. వాట్ ఈస్ ద వాల్యూ ఆఫ్ క్యూ సార్? క్యూ అంటే ద టోటల్ చార్జ్ ఆన్ ద ప్లేట్ కదా. ఎస్, టోటల్ చార్జ్ ఆన్ ద ప్లేట్. ఇప్పుడు try to write the Ampere circuit law. చెప్పండి అందరికి. So you are talking about displacement current, sir. It is equals to epsilon naught into d phi by dt. అదే కదా? Yes. So substitute the value of phi. చెప్పండి, I displacement is equals to epsilon naught into d by dt of phi. Phi అంటే ఏంటిరా? Q upon epsilon naught. ఇదే కదా? Yes. What is Q? What is Q? The total charge that has been deposited on the plates. జాగ్రత్తగా వినండి. ఓకే? Q is the total charge deposited on the plates రా. లేదా you can simply say Q is the charge that's flowing through the wires. అదే కదా, because it's an intermediate state. చూసుకోండి. So epsilon is a constant quantity. బయటికి తీసుకోండి. Your displacement current ID is equals to epsilon naught by epsilon naught. This denominator, it came out multiplied by d by dt of q. అదే కదా, q is only remaining రా. epsilon naught gone. అంటే మీ డిస్ప్లేస్మెంట్ కరెంట్ ID is equals to చెప్పండి dq by dt రా. dq by dt అంటే ఏంటి రా? ఇఫ్ యు ఆర్ ఇమాజినరింగ్ ద ఎంటైర్ ప్లేట్, ఆ ఎంటైర్ ప్లేట్ కోసం q is q ఓన్లీ కదా, dq by dt అంటే i. i అంటే ఏంటి సార్? I is the current. What current? The current that is flowing through the wires. అర్థం చేసుకోండి. ఓకే, the current that's flowing through the wire is same current, imaginary, okay, imaginary అంటే displacement current రా, జాగ్రత్తగా వినండి, is same equal to the current that is flowing between the plates, although it's not visible. Okay, although it is not visible, లేదా the effects are not seen, కానీ the current through the plates of the parallel plate capacitor, it is also equal to the current that is flowing through the circuit. So ఇప్పుడు let me just summarize everything in a format and we will end up this topic only రా. చూసుకో, too much discussion right. So this is your parallel plate capacitor, అంటే circular plate రా. This ఇదే మీ second plate and you are connecting them with wires, అదే కదా. yes, this is your battery, ఇదే మీ బ్యాటరీ. all of you జాగ్రత్తగా వినండి. రైట్, ఈ వైర్ లో యూ హ్యావ్ అ నార్మల్ కరెంట్, రెగ్యులర్ కరెంట్, అదే కదా. ఎస్, కండక్టింగ్ కరెంట్, కండక్ట్ వైర్స్ ఆర్ కండక్టింగ్ ఇది కదా. ఎస్, కండక్టింగ్ కరెంట్. సార్ ఎవ్రీవేర్ ద డిస్ప్లేస్మెంట్ కరెంట్ ఇస్ జీరో, కానీ బిట్వీన్ ద ప్లేట్స్ ద డిస్ప్లేస్మెంట్ కరెంట్ ఇస్ నాట్ జీరో. చూసుకోండి, when it comes to the area between the plates, there is a current. ఈ కరెంట్ అంటే ఇమాజినరీ కరెంట్, పేర్ అంటే డిస్ప్లేస్మెంట్ కరెంట్. అర్థమైంది? ఓకే, ఎస్, ఓకే, ఎస్. సో దిస్ ఈజ్ యువర్ డిస్ప్లేస్మెంట్ కరెంట్ అండ్ దిస్ ఈజ్ యువర్ కండక్షన్ కరెంట్. జాగ్రత్తగా వినండి, దే బోత్ ఆర్ సేమ్. అర్థమైంది కదా. దిస్ ఈజ్ అ ప్రూఫ్ రా. యువర్ డిస్ప్లేస్మెంట్ కరెంట్ ఈజ్ ఈక్వల్స్ టు యువర్ కండక్టింగ్ కరెంట్, అదే కదా. ఎస్, అంటే మీ డిస్ప్లేస్మెంట్ కరెంట్ ఐడి ఈజ్ ఈక్వల్స్ టు యువర్ కండక్టింగ్ కరెంట్ ఐ లేదా ఐసి. అర్థం చేసుకోండి. ఓకే, విత్ దాట్ బీయింగ్ సెడ్, లెట్ us డైరెక్ట్లీ జంప్ టు ద PYQs రా. కొంచెం PYQs తీసుకున్నాను, చూసుకోండి. I don't know, I think we will be able to finish these questions. First question, okay, first question. Such that చెప్పండి. A parallel plate capacitor, circular plates, charged such that it is increasing at a constant rate. Ante magnetic field arised due to the displacement current is are you even listening to me? చూసుకోండి. What is the value of displacement current? అందరి చెప్పండి. Right. Correct. Everybody knows option A is correct answer. కానీ what is the value of displacement current? అందరికి చెప్పండి ఒకసారి. Your dq by dt is constant. Okay. In the question itself, ఆ question లో ఇచ్చారు current increasing అంటే the linear charge density increasing at constant rate. అదే కదా, అంటే sigma increasing at constant rate అంటే q by a increasing at constant rate అంటే dq by dt some constant alpha. ఇదిగో ఇప్పుడు చెప్పండి, your displacement current id is equals to what is the formula sir? Epsilon naught into d phi by dt. అదే కదా, yes. అంటే epsilon naught can I simply say it is equals to I ra? Because at the end of the day we are simply going to get the same formula. చూసుకో, substitute చేసుకోండి and at the end of the day we are going to get the same formula. అంటే this is your displacement current I. చూసుకోండి, ఏదైనా loop you want, you can take it whatever loop you want, and you can try to find the magnetic field. కానీ the magnetic field will be maximum at the center. అర్థమైంది కదా? Yes. So your magnetic field is, where is the question? Right. So your magnetic field is maximum between plates. Yeah? Between the plates. Leda, let us take one more question. And I will just give you the question that is relating to this question. చూసుకోండి, these are my electric fields. అందరికి let us say the value of electric field E is equals to 12t square plus 60. Okay? And ఇదే your circle, the radius r is equals to చెప్పండి 7 centimeters. Question is find the displacement current. త్వరగా చేసుకోండి. You can tell me in terms of epsilon naught, లేదా you can also tell me at the end of of 1 by epsilon naught seconds, లేదా at the end of t is equals to 1 by epsilon. చెప్పండి. t 1 by epsilon naught అనేది చాలా పెద్ద నంబర్ రా. Not recommend you to go into the technical details, కానీ జస్ట్ ఆన్సర్ ఇవ్వండి. అదే ఇది కూడా చాలా ఓకే. ఇది చాలా సింపుల్ క్వశ్చన్ రా, ఎందుకు ఎంత కాంప్లెక్స్ చేస్తున్నావు అందరికి. Yes, sir. Along with topics, NCRT exercise or back exercise, take as a questions practice. I forgot your name actually. I'm sorry. చాలా టైం తర్వాత వచ్చింది కదా. Yes. Why only 40 marks? The most irritating thing for me is మీకు only 40 marks kavali physics lo. How are you planning your scores ra? Only 40 marks in physics ante how many in biology and how many in chemistry? Like how are you preparing your entire academics? I'm not understanding all of that. Okay? Just 40 marks, they are not nothing. 40 marks are nothing ra. Are you understanding? Okay. Yes, detailed, very extremely detailed handwritten notes, they are available. I will upload it. Okay, hi. Anyways, చూసుకోండి. So your displacement current ID formula ఏంటంటే, you can simply say, sir, displacement current ID is equals to epsilon naught into d phi divided by dt. ఇదే కదా? Yes. Substitute రా, epsilon naught is epsilon naught, d by dt of phi కావాలిరా, d by dt of phi. Phi అంటే ఏంటి? ఇప్పుడు ఎక్కడ నుంచి phi క్యాలిక్యులేట్ చేసుకోండి అందరికి. So you can simply say, sir, phi is equals to E into A. అదే కదా? E అంటే ఎంత రా? 12 into t square plus 6 into t multiplied by మీ ఏరియా అంటే pi r square. Pi r square సర్కులర్ ఉంటుంది కదా, సర్కులర్ ప్లేట్ ఉంటే pi r square. Take the value of pi as 22/7 into r square అంటే 7 square అంటే 7 gone రా. So you can simply say, sir, 154, right? 154 multiplied by 12t squared plus 60. అదే. So this is your flux. ఇదే మీ ఫ్లక్స్ రా. అంతే కదా? Yes. చెప్పండి. You can simply say, sir, 154 multiplied by 12t square plus 60. So ఈ 154 కాన్స్టెంట్ ఉంటే బయటికి తీసుకోండి. So you can simply say, sir, displacement current is equals to 154 multiplied by epsilon naught multiplied by, ఇప్పుడు డైరెక్ట్ డిఫరెన్షియేట్ చేసుకోండి రా. 24t plus 6 కదా? Yes. So it is 24t plus 6. చూసుకోండి. So nice. Anyways, even if you are substituting till this point, it is chaala. Yeah, this is good for me. Yeah, this is sufficient for me. సరే, 440, you will not even get the college రా. కేటగిరీ ఉంటుంది ఏదైనా. Are you from category? I don't know if you are having category. 440 is very good, very low score. And I think I should do extra session only on how to train your brains. Understanding, you are underestimating yourself a lot. Okay? A lot. 440 is nothing, to be honest. If you are scoring 300 marks in biology, చూసుకోరా అంటే, are you understanding your level? And if you are scoring 100 marks in chemistry but only 40 marks in physics ante, it is the what should I say? I should not even like, it is a very good thing. You understand me, 300 score ante you are a topper. Understanding 300 is a very good score. Chemistry lo kuda your 100 is, I would not say it's a very good score actually. No. At least expect 140 in chemistry, and physics lo kuda at least expect the same 140. And 280 plus 300 somewhere around 580. 580 ra. This is a decent score, I would say, decent score. Andariki. Okay, this should be your distribution. Ledante you can increase 10-20 marks in biology and reduce your 10-20 marks in physics and chemistry ra. Kani this is a very odd distribution of marks whatever you are doing. Okay, you need a guidance. I don't know who is. You really need a mentorship. Jagrataga, because you only have 3 months for your exam. E mentality unte everything will be gone. Everything can be started from scratch. But your confidence decides everything. Anyways, chusko. So here let us talk about EM waves, okay? Electromagnetic waves ra andariki. EM waves. EM waves gurinchi maatladutunna. Chuskondi. Okay. No. You have not given the proper attention plus time plus hard work for physics. Kabatti your physics is very weak. But you understand, okasari meeru physics baga cheste, your physics will at least get you 130-140 marks. Ade. Yeah. That is the biggest problem with the most of the institutes ra. They are not completing the syllabus at all. Kabatti we will complete the syllabus here first of all. Again, I'm telling you in each and every live of me, ikkada kuda malli cheptunanu chuskondi. The first thing that you will be doing is you go back and start seeing all of my lives ra, right from the basics of maths. Akkada nunchi start chesko, you watch each and every lecture, make proper notes ra. Proper notes ante take it very seriously. Endukante if you are not serious, okay, Hi. Take it very seriously, all of you. Take it very serious, because I know how the families do change ra. Okasari you have that apron wearing on your body ante you don't even know what sort of society respects you ra. Are you understanding? Your family, everything, your emotions, your friends, that pride, that arrogance is something else ra. You are wearing that white apron, you are having that stethoscope in your finished. Try to aim all those things, Ray. Okay. So, kabatti, the first thing that you have to that you require is work on your mentality, ra. Ide chala important. If your mentality is not good, and you are only thinking, sir, 100 marks in chemistry, 200 in biology, 30-40 in physics, gone. Try to understand. The first most thing that you will be doing is work on your mentality. Okay? Dream big. Dream big ante at least you think that nobody is costing you, nobody is charging you for thinking. Yes, you at least think in your mind that you will be scoring 330 in biology. Dan tarvata 140 leda 150 in chemistry, and at the same time 150 in physics. Ade, your score is somewhere around 630 ra. Are you understanding? Just think it in your mind. Just think it in your mind. And then we will make a roadmap to achieve every single thing of it. Try to understand what I'm telling. Okay? Things are very serious. They are regular kada. Kirti. We have 3 subjects, physics, chemistry and biology. So each and every subject has to be given proper amount of weightage kada. Kabatti the classes are arranged in such a way, but they are not discontinuous, okay? They are regular. Chusko, the biggest purpose for arranging your Arjuna batch in such a way is, first thing, you should get all equal weightage to all the chapters. The second most important thing is, because we are continuing, we are finishing the syllabus very quick, to give you the time to revise whatever has been completed. Are the understanding? Yes. Okay, detailed notes will be available. Choose score. Anyways, so you attend, at least think about this score. roadmap will be made later on. Effort, your hard work will be the secondary thing. Kani your primary thing you are failing it is your determination, your thought process. Okay, 650. Yes, very good, very good. Ippudu you tell everybody, hey, all of you in the comment section, nobody of you should have a target less than 630. Ade, this should be your minimum target. Understanding? This should be your minimum target of 630 in NEET examination. Then and only then you can at least go into the examination hall. Sir, 400, 440, 450 ante you will never even be sit in the exam. Are you understanding? If you are expecting somewhere around 700, my actual score it goes somewhere around 580 to 600. Understand? This is a lag. I am telling you. Understanding? If you are expecting around 700, I would not say 500, your expected score will go around 600 to 620. Are you understanding? If you are expecting 450 marks, until my actual score, it will go around 300. Because in the lower range, the score shifts very gradually. Yes, 660, 650, you expect at least that score. మీ దగ్గర determination ఉండాలి, మీకు motivation ఉండాలి. If you are not having any motivation, I will not say motivation, but at least there should be some plans. Okay, I'm not feeling good, my heart is broken because you are expecting such low marks and you are underestimating yourself so much. It gives me shock sometimes. Anyways, చూసుకోండి. Right. Thank you so much, Siri. Thank you so much. Yes, Praharshita. Very good. Very good. Your score should be at least 630. I would say at least 630 because it is achievable. It is achievable. I would say it is achievable. Okay. I'm not telling you 670 marks, 680, 690. Time constraint kuda untundi kada. Yes. Kani when you see the lowest score, it should be 630. At least keep in your mind, what will it be the final stage lo results ochina tarvata, what will be the score? That is a secondary thing. Okay, that could everything be managed. Kani ekkada vachi your target should not slip beyond 630 marks. Anyway, చూసుకోండి. EM waves lo Maxwell, okay, Maxwell has given us some idea. Idea ante enti, మీ దగ్గర ఒక charge particle ante enti sir? Take any metal, okay, take any metal and give it a charge. Let us say it's my sphere, point mass. Anyways, so you take any charge particle, okay, ఏదైనా charge particle తీస్తే, and let us say we are giving a charge of plus q on this particle అదే కదా. So the situation is you have a particle అంటే small sphere, point mass. ఈ point mass పై you are giving it some charge q. అదే. Now, yeah, but we will be completing in February only, okay? The syllabus here on Vedantu Telugu NEET channel will be completed by the end of February only. Choose. Okay, perfect. So if you are accelerating this charge particle, choose your acceleration ante it has two types. Ante enti sir, you are changing the speed, leda you are changing the velocity. Choose. Okay, very possible. Your score of 140 plus marks in physics in 3 months, very possible, very possible. I'm telling you, okay. In 3 months lo exactly you have 100 days right ikkada nunchi you have 100 days. In 100 days lo can you score 140 plus marks? Yes, for sure, okay. 100% you can score it. At least 140 is completely achievable. Kani ఈ స్కోర్ కోసం you need accuracy, you need calculations, okay, and you need the formula application. Ade ee moodu things unte your 140 plus is highly achievable target. If you want, I will be releasing a perfect video only ra. Anyways, చూసుకో. So మీ దగ్గర ఒక చార్జ్ పార్టికల్ ఉంటే ప్లస్ క్యూ చార్జ్ పార్టికల్, యూ యాక్సిలరేట్ అంటే ఏంటిరా చూసుకోండి. You accelerate this charge particle. Andariki accelerate ante you have two types of ways to accelerate it. The first way is keep the direction same, okay? Keep the direction same, but change the speed. Are you understanding? But change the speed. These are all the mechanics things I'm telling you. అంటే ఏంటి సార్, ఇదే నా చార్జ్ పార్టికల్, యు ఆర్ మూవింగ్ ఇన్ ద రైట్ సైడ్, యూ కెన్ క్లాసిఫై ఇట్ యాజ్ అన్ యాక్సిలరేషన్, చేంజ్ ద డైరెక్షన్. సో దిస్ ఈజ్ ఆల్సో అ టైప్ ఆఫ్ యాక్సిలరేషన్. లేదంటే యూ చేంజ్ బోత్ రా, యువర్ స్పీడ్ ఈజ్ ఆల్సో చేంజింగ్, యువర్ డైరెక్షన్ ఈజ్ ఆల్సో చేంజింగ్, అంటే యువర్ టోటల్ వెలాసిటీ ఈజ్ చేంజింగ్. అదే కదా. సో ఒక చార్జ్ పార్టికల్ ని యాక్సిలరేషన్ ఇస్తే యూ కెన్ సింప్లీ సే దట్ ఇట్ ఎమిట్స్ వేవ్స్. జాగ్రత్తగా వినండి, ఇట్స్ అ వెరీ ఇంపార్టెంట్ టాపిక్, ఓకే. క్లాస్ డ్యూరేషన్ విల్ బి టిల్ 8:30, ఓకే, 8:30. అదే రైట్. సో ఇఫ్ అట్ ఆల్ యూ హ్యావ్ అ చార్జ్ పార్టికల్ అండ్ యు ఆర్ యాక్సిలరేటింగ్ ఇట్, జాగ్రత్తగా, ఇట్ విల్ ఎమిట్ యువర్ EM waves. EM waves అంటే ఎలక్ట్రోమాగ్నెటిక్ వేవ్స్. హౌ ఆర్ దే గెటింగ్ బర్న్ అంటే సార్, how the electromagnetic waves are forming ra cheppandi. The process of formation of EM waves ante take a charge particle, ee charge particle ni give some acceleration, ade automatically it will emit EM waves. You understand, okay? Good. So sir, EM waves, let us go deep into it. EM waves ante enti ra? EM waves, E ante me electricity, something like this, sir. E for electricity, sir. E for electricity ante electric wave ra. Chusko ante E for your electric wave. Oh, what about M, sir? M ante magnetic wave. Ade, are you understanding? E for electric wave, M for magnetic wave. Ante EM waves lo rendu waves unnai ra. First one is your electric wave, the second one is your magnetic wave. But the direction, sir, direction of propagation of waves. What about the direction of electric wave? What about the direction of magnetic wave? Andariki chuddam. Chusko. So if at all you have two different components, okay, two different components, ante first is your electric field, the second is your magnetic field ra. Try to understand, this is your electric field, this is your magnetic field. When they are working together, this is your electric and magnetic field oscillating. And if you do the same thing and take them forward, something like this, chusko. So this is me electric field, this is your magnetic field. Try to understand, okay? Your electric field is up and down, ide kada. Yes, magnetic field is towards you, away from you, towards you, away from you, towards you, away from you, something like this. Ante z axis me kosam this becomes your z axis, ade kada. And this becomes your y-axis and this becomes your x-axis. Chuskondi. Ee waves lo your electric field is oscillating in y-axis, magnetic field is oscillating in z-axis, and the wave that is actually traveling in x-axis. Chusko. Something like this, okay? Something like this. Okay, this is your EM waves. Try to understand. Not necessarily electric field should be in the y-axis, it could be in the z-axis also. Ide me electric field unte, this is your magnetic field, okay? Ippudu they are traveling in x-axis. Ledante if this, how should I tell you? Yeah. If this is your electric field, chuskondi. Ippudu it has gone into x-axis kada. This is your x-axis. And this is your magnetic field ante y-axis too. And the wave is coming towards you ante z-axis. Chuskondi. Ardhamaindi kada? The only thing is that the electric field, the magnetic field should be perpendicular. At the same time, the direction of propagation of wave should be perpendicular to the direction of each and every component. Chusko. Okay. This is your EM waves. Jagrata. And if I say this is your electric field, okay, this is your electric field. See, up and down, up and down, up and down. Ante entira? Ante the electric field is coming like this. Chuskondi. Red color, red color, red color is your electric field. What about the magnetic field? Magnetic field is blue color. It is oscillating something like this. And what about the direction of wave? Moodu things unnai ra chuskondi. First one is your direction of propagation. Second thing is your electric field direction. Third thing is your magnetic field direction. Okay? All three of them. EM waves low, all three of them, they are perpendicular. Jagrataka. Okay? All three of them, they are perpendicular. EM waves low, all three of them, they are perpendicular. Are you able to understand? Right. Perfect. 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 Chuskondi. So this is the animation. Okay? Ide. This is your animation, right? And enti sir, so if red color is my electric field, let us say ide ra ide. So this is your electric field oscillating up and down. Chuskondi. But at the same time, see the direction of propagation. Okay? Direction of propagation ante right side lo untundi. Chuskondi. Ide the direction. Direction of propagation. Right. Idante na electric field andariki. Which plane is it ra? Cheppo. Your y-axis kada, it is oscillating along your y-axis. What about your magnetic field, right? Must be along your z-axis. Andariki, your magnetic field should be along the z-axis. Something like this, right? You try to understand. Not able to draw it on a plane. Kani, they are perpendicular. Okay? Ide me electric field up and down. Magnetic field ante something like this, ra. Okay? This is your magnetic field. This is your electric field. When they are oscillating together, it is becoming an EM wave. Okay? Perfect. 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 Ippudu to understand further, ra. Meeku koncham. Okay? Meeku so to understand the further syllabus, okay, to understand the further topics, the equation of a wave is generally written in two parameters. The first is your displacement లేదా position అంటే x లేదా y లేదా z చూసుకోండి. అంటే this is your position parameter. This is your position parameter. The second parameter is your time. Are you understanding? Yes. So these are the two parameters to write the equation of any wave. Any wave. Mari how to write it? Let us see. Chuddam andariki. The equation should be written something like this. Chuskondi. Y is equals to a times of sine leda cos. Whatever you want to take, you can take it. Okay. A sine of kx plus or minus omega into t. Chusko. Ante y is what, sir? Y is the y displacement of the particle. Chuskondi. Just try to understand what I'm telling you. Okay. Ledante you can also write, sir, z is equals to a times of sine of kx plus or minus omega t. Ledante you can also see, sir, x is equals to a times of sine f. Kani ippudu the variables will change. Okay, you should say k into y plus or minus omega into t. Ledante x is equals to a times of sine of k into z plus or minus omega into t. Ledante x has gone kada, y. One more is left for y. Let us take y is equals to a times of sine of k into z plus or minus omega t, and z is one more remaining. Z is equals to a times of sine of k into y plus or minus omega into t. Chuskondi ra. Parameter ante enti ra? Okay, parameter ante enti? Parameter in the sense, sir, whatever is there in these brackets, chusko andariki. So can I simply say immediately after k ra, you have position term. Chusko here y ante y axis lo position, x ante x axis lo position. y అంటే y axis లో పొజిషన్, x axis z axis లో పొజిషన్ చూసుకోండి. అండ్ హియర్ యూ హ్యావ్ ద సెకండ్ పారామీటర్ అంటే టోటల్ టైం. ఇదే కదా? ఎస్. సో టు రైట్ ద ఈక్వేషన్ ఆఫ్ ఎనీ వేవ్ మీకు రెండు పారామీటర్స్ ఉండాలి. ద ఫస్ట్ వన్ ఈజ్ యువర్ పొజిషన్ పారామీటర్ అండ్ ద సెకండ్ వన్ ఈజ్ యువర్ టైం పారామీటర్. అందరికి జాగ్రత్తగా వినండి. ఓకే, ఇప్పుడు వాట్ డూ యూ మీన్ బై దిస్ y, దిస్ z and this x? చూసుకో all of you. If your wave is oscillating up and down ra ante y axis kada, yes, so at any given time the position of that point that is oscillating up and down is known as the y. Ledante if your wave is moving in z axis ante enti sir, this something like this చూసుకోండి, coming towards you, going out of you, coming towards you, going out of you, something like this. Are you able to understand? In cases lo you take z as the equation in the left side, sorry, the left side of the equation, and in the last when the wave is moving something like this and x axis kada, x axis. So if this is x axis you will be taking x to the left side. Andariki vinandi. Okay, yes. Hi, good evening. So your wave is usually represented by two different parameters. First parameter ante me position, second parameter ante me time. Ide kada? Yes. So let us imagine ra, this is the electric field. Cheppandi which axis it is moving ra? Which axis is your electric field moving into? Can I say y axis sir? Up and down చూసుకోండి. అంటే yes, your electric field is oscillating in your y direction. E bar is oscillating in y axis. ఇదే కదా? Yes. అందరికి. So what will I write sir? I will write Ey, చూసుకోండి, Ey of the equation left side లో is equals to a లేదా a అంటే amplitude రా, a అంటే amplitude, a అంటే the maximum position. చూసుకోండి, this is the midpoint of the wave కదా, a అంటే the maximum position, లేదా you can also say it should be the amplitude. అందరికి. So this is the value of a. Since we are talking about electric field రా, electric field, it is the amplitude of electric field kada, we have a special name, E naught. You can take sign. ఇప్పుడు the biggest question is what parameter should I take? అదే కదా, first should be position, second should be time. Time ki ante I don't have any problem. Time must be omega into t raade. Try to understand all of you, okay? I don't have any problem for a time parameter. It must be omega t all the times. మొత్తం సారి you can take it omega into t. కానీ when you're talking about the position parameter, ఇప్పుడు you will have to check for the direction of wave. Where is it going ra? Where is the wave going? Where is the wave going? I started from left side, up and down, kani I'm eventually moving this wave to the right side. Ante kada? Yes. So if your wave is to the right side of what? Which axis? M axis ra. This is your x axis. Yes. Ante your position will be x. You can simply take kx sir. Are you understanding? But little twist, okay? Little twist. Andariki jagrataga vinandi, okay? All of you be very careful. Even ఈ x axis లో మీ దగ్గర రెండు possibilities ఉన్నాయి. The first possibility is your wave is traveling to the left side. లేదంటే your wave is traveling to the right side. Andariki. I am telling you the shortcut, okay? If your wave is traveling to the left side, see the symbols. How did we do, sir? First of all, we talked about the direction of oscillation of electric field. Y-axis lo unte I have written Ey. The amplitude is the second thing we have talked about, E naught. Ade kada. Ippudu we taken sign and ippudu naaku rendu parameters kavali ra. The first parameter will be position, the second will be time. I don't care about time, I will simply write omega into t ra. Andariki. I want all of you to focus on here, okay? Ippudu when it comes to the position, y already ochindi kada. I had the option of x, leda I had the option of z. Z kuda z axis kada. We have seen the direction of motion of wave ra. This wave is moving to the x axis. Ante kada. Kabatti instead of z, I am taking x. K will be remaining k only ra. Whenever you have x, you will be writing k. Whenever you have t, you will be writing omega. చూసుకో, ఇప్పుడు x axis లో కూడా మీ దగ్గర రెండు possibilities ఉన్నాయి. The first possibility is your wave is going to the right side, left side, లేదా your wave is going to the right side. ఎలా డిసైడ్ చేయాలంటే you see the signs of k, అంటే plus k and plus omega. రెండు కూడా పాజిటివ్ కదా. If both are positive, the wave is moving to the left side. లేదంటే both are negative, minus k minus omega. Both are negative. అంటే సేమ్ సైన్స్ ఉంటే the wave is actually traveling to the left. And opposite sides ఉంటే, for example, plus k minus omega లేదా minus k plus omega ఉంటే your wave is traveling to the right side. చూసుకోండి. So I have to decide అంటే I've told you that this wave is moving to the right. అంతే కదా. So right అంటే this symbol should be minus. అదే. Are you able to understand? అందరికి. How many of you are able to understand? ఇప్పుడు let us take one more question, okay? తీసుకోండి. So ఇదే, this is your y-axis, this is your x-axis, this is your z-axis. Okay, I want to tell you about the direction of propagation of waves అందరికి. So ఇదే మీ z-axis, ఇదే మీ x-axis, this is your y-axis. Okay, tell me some rough approximations. ఇదే మీ origin రా అందరికి. Okay, లేదంటే let me also change the colors of the axis. Okay, z-axis అంటే మీ red color రా, all of you. So whenever you see the red color, you understand that the wave is actually moving to the z-axis. Okay, z-axis. ఇదే మీ z-axis. Your y-axis has a color of blue. Leda, you take this color. You can take white color only. So your y-axis is having a color of white, and your x-axis is having a color of ide kada. So now I'm telling you this. Chuskondi andariki. Ide, this is your wave. This is your wave. Ante direction enti ra? Cheppandi. First of all, tell me, and if I am telling you that this is a magnetic field, B bar, magnetic field oscillating in the EM wave, ante kada. So if this is your B bar andariki, how will you write the equation? The first thing you will do is see the oscillation of the magnetic field, ante along what axis. Chusko. I have written this wave with a red color. Red color ante aim axis ra, z-axis. Z-axis ante your magnetic field is oscillating something like this ra, back and forth. Me kosam back and forth ante something like this. Choose something like this. Are you able to understand? Back and forth, like this. Are you understanding? Ante z-axis ra. Z-axis unte what will you write, sir? What will you write? Cheppandi andariki. Can I simply say, sir, magnetic field is in the z-axis ante BZ. It must be equals to the maximum amplitude. Equation ra, SHM ki standard equation, A sin omega t plus kx. Ide kada. Position. Yedaina, you know, take it whatever you want to call it, you can call it. Okay. Ippudu, once you have found the direction, take the amplitude ra. Amplitude will be B naught. Electric field unte amplitude will be E naught, magnetic field unte B naught ra. Okay, amplitude is B naught. It's also a random value. Ide, this value is B naught andariki. Ippudu sin teeskovali. So you can simply say, sir, sin of kani rendu parameters unnai. First one is position, second one is time. I have told you whenever the parameter is time, directly write omega t. Ade. Okay, omega t complete, sir. Ippudu when it comes to position, what position should I take? For the position should be the direction of propagation of wave ra. Okay. The direction of propagation of wave. Cheppandi. The direction of propagation of wave. What direction? Where is the wave going ra? To the right side, ante x-axis. Ante x-axis. X ante you write x and you should take k only ra. These are fixed constants. Okay. K and omega should be fixed. For every equation, they should be written like that only. Chusko. Ippudu the problem is the wave is going to the right side, leda to the left side ra. Chusko. What did I write? If the wave is moving to the right side, sign should be opposite. Ante kada. If it is moving to the left side, signs should be same ra. So kasari if you have taken plus, you take minus. Ade opposite signs. So this is the equation of your magnetic field of the wave. Ardhamaindi andariki? Now let us talk about electric component also రా చూసుకో. సో ఇప్పుడు electric component కోసం I am taking this as my electric component అందరికి. This is my electric component. All of you tell me what should be the electric component value. E of what axis should I write ra? B in the z axis కానీ E in what axis చెప్పండి. E కి యాక్సిస్ చెప్పండి అందరికి. వాట్ కలర్ did I write E? Very good Gitanjali, very good. EY. Why sir? Because white color, చూసుకోండి, white color is for y axis అంటే your E is moving up and down. Format should be same. B, you are immediately taking B naught, ఇక్కడ you will be taking E naught, right? E naught అంటే amplitude of the electric field, అదే కదా. Yes, E naught into sin also you take the same thing, sin of something రా. కానీ ఇప్పుడు కూడా నాకు పారామీటర్స్ కావాలండి, చెప్పండి. So what should be the parameter, sir? Time parameter, I will simply write omega t, no problem into it. Omega t is omega t. What about position? Should it be x? Should it be y? Should it be z? X, y, z. M తీసుకోవాలి. For position, what should I take? Your x, your y, or your z? Where is the wave moving, Ra? Where is the wave moving? So your position parameter, it is decided by direction of propagation of wave రా. ఇది చాలా ఇంపార్టెంట్. ఓకే, డైరెక్షన్ ఆఫ్ propagation of wave. చూసుకోండి where the wave is getting propagated. Very good. Kx, x, this is the x axis రా. చూసుకో, your electric field is going to the x side kada. So yes, k into x. ఇప్పుడు what sign should I take? Plus, minus, plus, or plus, minus, plus? Just see, your wave is moving to the right side lo unte your sign should be opposite. You can simply take plus k minus omega t, లేదా minus k plus omega t. That also works. Okay, so this is the equation of your electric field and this is the equation of your magnetic field. అందరికి అర్థం చేసుకోండి. ఓకే, ఇది చాలా ఇంపార్టెంట్ రా. Let us take one more case and we will be winding up. Okay, so ide me x axis, this is your y axis, okay, and this is your z axis. Andari, and this is your z axis. Okay, x axis, y axis, z axis. Ippudu I am telling you that your electric field is oscillating something like this. Okay, electric field. What about the magnetic field, sir? Your magnetic field is oscillating something like this. This is your magnetic field. Naku equations kavali ra andariki. I want the equations. Okay, I want the equations. Not completed. We have a little more topic. We have to talk about energies, momentum. Then the chapter will be completed. Intensities. 3 things we have to talk. Dan tarvata your chapter will be completed. Okay, PYQs ante PYQ kuda తీస్తుంది. Tell me the equations, ra. Just random equations. Okay, first of all, your E bar, ra. E bar direction cheppu. Where is the direction of E bar? E bar is in the color. You can decide that only based. My drawing is very bad. Okay, I'm sorry for that. You're not getting the feel because of the drawing. But అర్థం చేసుకోండి అందరికి. Duration will be 8:30, mostly by 8:30 ra. Your class duration will be till 8:30. లేదా 8:25. We will end at 8:25. Okay. No, if we will be covering all those 2 hours or not. Not y-axis. Not okay. It's not a purple color, right? It's not a purple color, ra. Purple color is red plus blue. Okay, purple color is red plus blue. This is some sky color, ra. Okay, sky. You can say it is a sky color. No. No. Selective chapters ante you complete your modern physics first. దాని తర్వాత complete your electrodynamics. అదే you can take, there are two big branches actually. Physics లో రెండు చాలా పెద్ద branches ఉన్నాయి. The first one is mechanics and electrodynamics. So if you don't have time, you can take electrodynamics with your modern physics, and at the same time you can, if possible, cover waves and heat. Other waves and heat. But looking for this 100 days time, you can at least cover entire syllabus. Make the formula list. చూసుకో. E bar ante this color color చూసుకోండి. Which axis the color is matching, sir? Z axis is matching ante your E is in the Z axis. అదే కదా, it must be E naught into sin. అదే కదా, E naught into sin. ఇప్పుడు you have two parameters. Time unte you can simply say omega t. Now what about position parameter? It is moving along y axis, so it should be k into y. And since it's moving in positive y axis, one should be plus, one should be minus. అర్థమైంది కదా? BZ, okay, E naught EZ. And your B ante your B చూసుకోండి. The wave color చూసుకోరా, white color కదా. So white color ante ఏం axis రా? X axis. అంటే your B is oscillating in X axis రా. So it should be B of X equals to B naught into sin of, ఒకసారి you have written this parameters for electric field, same parameters for magnetic field. They don't change, okay? They don't change ra andariki. They don't change. Parameters for electric and magnetic field are the same andariki. Okay? B should be in the X axis, E should be in the Z axis. చూసుకో, this is in the X axis, this is in the Z axis, and the propagation is in the Y axis. చూసుకో, X, Y, Z. Completed kada? Yes. Very good. Very good. But. Okay, not but. I would add. In addition, చూసుకో, your equation of electric field will be something like this. E is equals to E naught into sin of something. Okay, I'm not interested whatever it's there. Similarly, B is equals to, ante our magnetic field should be B naught into sin of something. I'm not interested in this. చూసుకో, E naught and B naught, they have a relationship. జాగ్రత్తగా వినండి. Okay, E naught and B naught, they have a relationship. What is the relationship, sir? E naught is equals to B naught into C. C ante enti ra? ఈ ఫార్ములాలో C is your speed of light. Speed of, each and every formula that I'm giving you is keeping a huge significance. Okay, huge significance. Mari, what are the questions they will be asking? The questions that will be asked are of some this form. Chusko. I will be taking some PYQs. Okay, some PYQs. Chusko. The question is NEET 2025 only. Okay, see the same chapter, two questions in NEET 2025 itself. Okay, 2025 itself. Chusko. The first question, this is the second one kada. We have solved already the first one. The electric field, the electric field లేదంటే let me just take one more formula, okay, because I think one more formula is required for this. చూసుకోరా. So now let us talk about three different regions kada. Yes, అంటే your electric field E bar, let us say it's oscillating in Y axis ra. మీ magnetic field B bar, it is oscillating in X axis, then the propagation must be along the Z axis. ఇదే కదా. ఇప్పుడు డైరెక్షన్ గురించి చెప్పండి. డైరెక్షన్స్ చూసుకోండి అందరికి. The direction shows something like this, okay? E, B, C. Good petkondi. These are the three letters. E ante electric, B ante magnetic, C ante speed. Not speed of light, speed of wave. Speed of wave. C is the speed of wave, okay? C is the speed of wave. Ante direction of propagation. ఇప్పుడు directions గురించి మాట్లాడుతాం చూసుకోండి. E ante direction of oscillation of electric field. Next, B ante enti sir? B is direction of oscillation of magnetic field, okay? Magnetic field. Similarly, C ante enti ra? Direction of propagation of wave, okay? Direction of propagation of wave. Directions గురించి మాట్లాడుతున్నావు అందరికి. Only direction, okay? Only direction, not about the values ra. Letters, you understand the terminology. First E, దాని తర్వాత B, దాని తర్వాత C, okay? And the cross product remains the same. మీకు E bar కావాలంటే E bar ki direction E bar ki direction కావాలంటే take the cross product of the remaining two రా. అంటే B bar cross C bar. ఇదే కదా. Similarly, మీకు B bar కావాలంటే continue. Go to the right. C bar cross E bar. Okay? And మీకు C bar కావాలంటే go from the next part రా. E bar cross B bar. ఇదే కదా. E bar cross B bar. You can simply say something like this రా. ఇదే E bar, this is B bar, this is C bar రా. Direction is something like this. E bar cross B bar is C bar. B bar cross C bar is E bar. లేదా C bar cross E bar is B bar. చూసుకోండి. B bar cross C bar. B bar cross C bar is E bar. Similarly, C bar cross E bar రా. C bar cross E bar is B bar. And E bar cross B bar is C bar. ఇదే కదా. So these are the cycle that you have to remember. ఇదే directions గురించి మాట్లాడుతున్నాం అందరికి. Only directions kada? Yes. With that being said, you also remember one more table. What is the table? Table is something like this. I've told you in the vectors to remember I, ide na J, and this is my K ra, something like this. I bar cross J bar will give you K bar. J bar cross K bar will give you I bar, and K bar cross I bar will give you J bar. Ide kada? Are you understanding? Good. The electric field is given. Let us take the question. Okay, let us take the question. Yes, it is given by. I think you have the tools available. It is given by Ez ra. Jagrataga chuskoni andariki. Ez is equals to 60 into cos of 5x plus 1.5 into 10 to the power 9 volt per meter. Full stop. The expression for the corresponding magnetic field. And such type of questions are asked in JEE mains. Chala frequent ga, okay? The corresponding magnetic field equation. Option A ra, తీసుకోండి. Your Bx is equals to 2 into 10 to the power minus 7 cos of complete. Next, your By is equals to 60 into sine of everything. Okay, this ante ee mottam ra. Okay, it will not change. I've told you it will not change. Okay, it will not change. Option C ra, your B in the z axis, sorry. Your B in the z-axis is equals to 60 into cos of mottam. And lastly, option D, your B in the y-axis is equals to 2 into 10 to the power minus 7 into cos of complete. Take it. So, mudatiga, you calculate the directions, okay? Calculate the directions of E bar tell me where the wave is moving ra. C bar E bar ki direction calculate chesina tarvata you can talk about direction of B bar ra. Modatiga you try to understand, okay? Whenever we were writing the equation for E, andariki chuskondi, whenever we were writing the equation for E, what did we say? E naught into sine kada. Similarly, when we are writing B, it should be B naught into sine. It is ide kada. Yes, you understand the relationship ra. Okay, you understand the relationship. What did I say? I've told you E naught is equals to B naught into C if it's an electromagnetic wave. Ade kada. Yes. They're telling that it's an electromagnetic wave kada. Yes. You understand now, okay? B naught into C ra. It is, can I simply say, sir, B naught is equals to E naught divided by C. Chuskondi. E naught ante E naught, C value is how much ra? 3 into 10 to the power 8 ra. Ante it is E naught by 3 into 10 to the power minus 8. So this is your B naught. You can understand the values. 10 to the power minus 8 ante B naught is very small. Very small magnetic field will be there and significant amount of electric field will be there. Understanding? So your light is also a part of electromagnetic waves. Ante whatever observable light you are observing ra, ee light daggara it has some electric field and some magnetic field also. Take the torch of your mobile, okay? Take the torch of your mobile. Whatever the lights that are coming from this torch, it has both the things, okay? Choose only. This hand, whatever I am feeling, this light, this brightness has electric field also, magnetic field also, okay? Right. Choose one. So your magnetic field will be very less ra, chaala takwa, very less as compared to your electric field. Choose one. Your E naught is 60. You divide it by this number, right? It gets very small. Ante this 60, they are gone, obviously. Not possible at all. Now, what about your B bar value ra? Ante ippudu na daggara rendu options unnai kada, x axis and y axis. Ade the only thing that you have to observe is x or y. How do you observe, sir? You understand the direction of E bar, C bar and B bar ra. What did I say? Your B bar should be equals to C bar cross E bar. Ide kada. This is the formula. C bar direction ante enti ra chusko. Your x is positive. Your t is also positive. Rendu positives unte it should be in the negative direction, negative x-axis, ante minus I cap. Chusko. It should be minus I cap cross E bar. E bar ante enti ra? Z-axis. Minus I cap cross K cap ra. What is the value of minus I cap cross K cap ante? It should simply be equals to J cap. How to understand, sir? Minus I cap cross K cap. Chusko ra. I cap cross K cap. Leda, you can simply say, sir, K cap cross I cap is equals to J cap. From this cycle, from this cycle. Take the reverse. Take the reverse. What is the reverse, sir? Minus I cap cross K cap, kada? Yes. So you can simply say I cap cross K cap is minus J. You are reversing it. And take a minus ante minus I cap cross K cap ante minus of minus J. That means plus J. That means your magnetic field will be in the y direction. Ledante, even if you are not understanding this, you understand, okay? Z already came. X already came. Y is left. This is Y. It should not be X. Ante kada? Yes. So this is how we talk about it. Ardhamaindi andariki? Yes. Very good. Very good. Very good. Very good. Ippudu let us fastly talk about some terminologies. Chuskondi. Let us talk about energy densities. Andariki. Okay? Energy densities of an EM wave. Choose. You have two types of energies. The first one is the electrical energy density, okay? Electrical energy density. You can simply say, sir, energy density electrical is equals to half epsilon naught E naught square. Ade, leda 1 by 4. You can take it 1 by 4, okay? I'm talking about energy density kada 1 by 4. And when it comes to your magnetic density ra, andariki, these are only the formulas that you have to remember, okay? Magnetic energy density. It could be given as 1 by 2 B squared upon mu naught. లేదా B naught squared by mu naught. These are the formulas. కానీ గుర్తుపెట్టుకోండి, for an EM wave రా, for an EM wave both are the same. అంటే ఏంటి సార్? both are same అంటే ఏంటి రా? Your expression epsilon naught E naught square is equals to B naught square by mu naught. How did we come, sir? How did we come to know, sir? Because your speed of light is 1 upon root of mu naught into epsilon naught. This is a formula. Idi kuda gurtupetukondi andariki. This is a formula. This is a formula. You use it, you come to this result. How to use, sir? You can simply say, sir, B naught into C is equals to E naught kada. Yes, square cheskondi both sides lo. B naught squared into C squared is equals to E naught squared. C squared ante idi square kada. Yes. So B naught squared multiplied by C square is 1 upon mu naught into epsilon naught is equals to E naught squared. You send this epsilon naught that side and you are left with this formula. Ante your B naught square by mu naught is equals to your epsilon naught into E naught squared. That means your total energy density, okay, total energy density is equals to addition of both kada. Yes, is equals to 1 by 4 mu naught, no, not mu naught, it should be epsilon naught E naught squared plus 1 by 4 B naught squared divided by mu naught. Both are same, both same until you can simply say it is half epsilon naught E naught squared or half B naught squared by mu naught. So this is all about the energy densities. Okay, so when you're talking about the last topic, okay, intensity, because we don't have much time, what is the time? 18 kada, we will have to finish it by 25. Choose. So we are talking about intensity of the waves, okay, intensity of electromagnetic waves. So intensity ante I kada, electric field intensity is simply equals to energy density into speed of light. So you can simply say 1 by 4 epsilon naught E naught squared multiplied by C. Similarly, your magnetic field intensity is 1 by 4 B naught squared by mu naught into speed of light into C. That's it. So these are the intensities of the lights. Dan tarvata, let us talk about your electromagnetic spectrum. Choose. You try to understand, okay, EM waves ante it's a wave. Choose. EM wave ante it is a wave and every wave has two parameters. Choose. Every wave has two parameters. The first one is the wavelength. Yes. And what about the second parameter, sir? The second parameter is the frequency. Andariki. Wavelength ante lambda, frequency ante f. And you can simply say, sir, speed of light leda frequency is equals to C upon lambda. C ante speed, lambda ante wavelength. You can also talk about the energy of EM wave. Energy of wave is equals to H into C by lambda, and momentum of wave is equals to H upon lambda. Okay, we will be seeing this in your modern physics. Okay, de Broglie hypothesis. Anyways, choose. So based on the wavelength, choose. Based on wavelength and frequency, if your wavelength is maximum, your frequency will be minimum. Inversely proportional kada. Yes. Jagrata. And if your wavelength is more, frequency will be less. Wavelength ante sir? Wavelength ante it is a distance of a wave. It is a wave kada. Yes. So in this wave, jagrata choose. Started from here, completed upper section, lower section, came back to the original position. And this is a wavelength ante lambda ante. So if you talk about your different wavelengths, we have different types of waves. Choose. Kani deentlo kuda we can simply say whatever light you are observing, that has a typical range, and we say it's a visible range. Andariki, visible range. Okay. Ippudu, I don't know if you know this or not, but this name is to be remembered. Vibgyor. Okay. Vibgyor. So ide me visible range. Violet, indigo, blue, green, yellow, orange, red. Okay. And when you go left to right, wavelength increases. Okay. Lambda increases and opposite. And your frequency decreases. Okay. That means what, sir? That means the wavelength of red is the maximum, wavelength of violet is minimum, frequency of violet is maximum, frequency of red is minimum. Yes. So based on it, the types of waves are choose. Total types are this. Okay, these are the total types. Andariki. Start from there. Gamma rays wavelength అంటే 10 to the power minus 12 meters రా, చాలా చిన్న, very low, very low, and it is existing at a very high temperature. చూసుకోండి, this is the temperature range, okay? Approximately equals to 10 million, it's 10 million, okay? 10 million degrees Celsius, it is the temperature of your gamma rays, చాలా high. So whenever you have those nuclear reactions going on, stars blue, whenever the stars are forming, big bang, all these things, your gamma rays are emitted. దాని తర్వాత you keep on increasing the wavelengths. Gamma rays తర్వాత you have the X-rays that is used in the hospitals కదా. Yes, the wavelengths are 10 to the power minus 10 meters. This is expected from all of you to remember. అందరికి గుర్తుపెట్టుకోండి. There was a question in NEET, tabular form, okay? Tabular form రా. అక్కడ they asked you about the ranges. చూసుకోండి, X-ray తర్వాత ultraviolet rays are there. Sun, UV rays, whatever that penetrate into your skin. You apply sunscreen kada, yes, to save from this. Visible range ra, ee visible range lo you have this your entire spectrum, vibgyor, starting from violet. Chusko, visible lo kuda violet, indigo, blue, yellow, orange, red. Vibgyor, okay? Violet, indigo, blue, green, yellow, orange, red ra. Starts from right side. Vibgyor, something like this, okay? Vibgyor should be something like this. Visible dan tarvata infrared, then microwave, and then radio. Radio waves do have huge wavelengths, okay? Their wavelengths may range in the terms of kilometers. Kabatti, a station is here, but entire city can listen to the signals kada, because it has a huge wavelength. Chuskondi. Are you understanding? When it comes to microwave, your oven ra 10 to the power minus 2 meters. అంటే 1 centimeter, something like this, okay? Infrared 10 to the power minus 5 meters. Are you understanding? Something like this, okay? Next, you talk about your ranges and you talk about your frequencies, okay? But the only thing that is required is you must remember the values of the wavelength, ante, okay? Good. With that being said, let us talk a little about, what is the time, Ra? 24. Yeah, it's okay. We can end the session, okay? Andariki. I think it's more than sufficient because I do have one more session. Okay, your EM waves. Sorry. And one more thing, all of you, okay? All of you. This video in the description section, you do have some test series that are organized. Okay, I recommend all of you to attend them, right? Perfect. Okay. So bye-bye everybody. Bye. Good night, all of you, good night. Right. Ratnadeep, the chapters are modern physics, entire modern physics, okay? Modern physics dan tarvata you can go for electrodynamics, electrostatics, current electricity, capacitors. Electrostatics, current electricity, capacitors, magnetism, EMI, AC. Okay? Yes, thank you so much, Parimala. And then you can also take your SHM, Simple Harmonic Motion, waves, wave optics. Okay, if you want, you can end it till this point only. Thank you so much, all of you. Right. Bye.